Hi friends, in this video we are solving the problems based on Rolle's theorem. Okay, now verify the Rolle's theorem for the following functions. First one, f of x is equal to x minus 1 into x minus 2 in closed interval 1 2. And second problem is f of x is equal to x minus a whole to the power of m, x minus b whole to the power of n in closed interval ab. And third one is f of x is equal to log of x square plus ab by x into a plus b in closed interval ab, where a greater than 0 and b greater than 0. Because this is logarithmic function, that is why the domain they are mentioned clearly, a greater than 0, b greater than 0. Right. Now coming to the first problem. Here the given f of x is equal to x minus 1 into x minus 2, where they are defined in closed interval 1 2. Is this function is defined or not, which is multiply inside, then what you are getting, you see, x square minus 2x minus x, that is minus 3x plus 2. So this is algebraic function, a quadratic polynomial. Yes or no? Quadratic polynomial or not? Yes. So this quadratic polynomial, every algebraic polynomial is continuous, that you know very well. See, x square is continuous, x is continuous, constant function is continuous, so f plus g plus h is also continuous. So by the definition, what you can say, every algebraic function is continuous means f of x is continuous on where closed interval 1 2. Next one, f dash of x, check it. What is f dash of x? Here we have 2x minus 3. 2x minus 3 is a linear polynomial. Okay, now polynomial of degree what? 1. So this is also exist or not? Is it defined or not? For every value in between 1 and 2, finite only now. You are getting put 1.5, 1.3, 1.2, 1.9, 1 and 2. You are getting finite value. So this is exist. Nothing but f of x is differentiable on open interval 1 2. Rolle's theorem definition, you have idea na? I'll repeat again. You see, f be a real valued function defined on closed interval a comma b, and is such that f is continuous on closed interval ab, and f is differentiable on open ab, and f of a is equal to f of b, then there exists at least one at least one point c belongs to open ab in such that f dash of c is equal to 0. This is Rolle's theorem statement na? Now we are proving this one only. Anyway, f dash of x is also exists. Second condition is also satisfied. Next, f of a. Third condition, f of a means f of 1. What is f of 1? We have put x is equal to 1 here. 1 minus 1. 1 minus 1 means 0. 0 into non-zero is 0 into this something is 0. Okay. Next, f of b here. f of b means f of 2. f of 2, if you substitute, 2 minus 1 is 1. 2 minus 2 is 0. 0 into 1 is 0. So what you can say from this, f of a is equal to f of b. So f is a real valued function defined on closed 1 2, and if it is continuous, also differentiable, and is such that f of a is equal to f of b. So Rolle's theorem 3 conditions are satisfied or not? Then what will happen? There exists at least one point c belongs to open interval a comma b such that f dash of c is equal to 0. Now we have to verify. For this verification, we are doing verification. Verification means f dash of c is equal to 0. You have to take. What is f dash of x? I have 2x minus 3. Then f dash of c is 2c minus 3 is equal to 0. So 2c is equal to 3. c is equal to 3 by 2. Now 3 by 2 is equal to 1.5. Is 1.5 belongs to 1 and 2? Yes. So verification is completed. So like this we have to verify the Rolle's theorem and find the c value. And the second problem, we have x minus a power m into x minus b power n. Okay, in closed interval a and b. So I am writing here, the second problem is f of x is equal to x minus a whole to the power of m, x minus b whole to the power of m on or n closed interval ab. Now you observe, x minus a is a polynomial of degree m, x minus b is a polynomial of degree n. So the product will become f of x is a polynomial of degree m plus n. So which is continuous or not? Every algebraic polynomial is continuous. So which is continuous on closed interval ab. First condition is okay. Now go for second condition, that is f dash of x find out. Product of two functions we have. So go for UV rule. First term into x minus a power m into first term into second term derivative x minus b power n minus 1. Inner derivative is 1 plus second term into x minus b power n into first term derivative is m into x minus a power m minus 1 into inner derivative what you have 1. Now f dash of x is this one. Now from this two you can take a common term or else you can leave this one. Now this is a polynomial of degree m, here n minus 1. So which is also what? Algebraic function only, now again it is. So this is algebraic function, algebraic polynomial of degree m plus n minus 1 or else n plus m minus 1 we have. Okay now in this case which is exist or not? Exist is exist. What is exist here? F dash of exist. What is mean by exist means while giving the values in between a and b, then it will become finite. F dash of x is finite. Then you can say f dash of x is exist on open AB. Now go for f of a. Endpoints we have to check. F of a. F of a means a minus a is how much? 0. 0 into a minus b power n is 0. Now f of b. F of b means b minus a power m into b minus b is 0. Therefore f of a is equal to f of b. So Rolle's theorem 3 conditions are satisfied or not? Yes. So go for verification. Verification what we have to take means first we have to take f dash of c is equal to 0. Then we have to prove there exists c belongs to open AB. So what is f dash of x I have? You see x minus a power m into n into x minus b power n minus 1 plus x minus b power n into m into x minus a power m minus 1. So in place of x you put c and equate to 0, then f dash of c is equal to 0 you will have. Now c minus a power m, n is there, n I am writing left side, into c minus b power n minus 1 plus here m is there, m I am writing left side, then c minus b power n into c minus a power m minus 1 is equal to 0. From this what you can take common term? You see c minus a power m is there, c minus a power m minus 1 is there. Which is highest here? M is highest. Least is what? M minus 1. So least term will common now. Suppose I have ax square plus bx I have. Then what I can take common? X I can take common now. Least term is degree is what here? 1. Here degree is what? 2. So degree 1 least term now. So you can take x is common. Here also what I can take common? C minus a power m minus 1 is a common. Next c minus b power n minus 1, c minus b power n you have. So c minus b power n minus 1 is a common. Then the remaining term is n into c minus a plus m into c minus b. That's it. Is equal to 0. Now you observe a into b into c. Now I am simplifying this and then I will get one value. First of all I will simplify that one. Then I will have c minus a power m minus 1 into c minus b power n minus 1 into this is nc plus c if I take in common n plus m. N plus m I wrote here. Next I can take a, this is you see what I have the remaining term minus an minus bm is equal to 0. Now product of three functions are 0. 1, 2, 3, 0. If this is equal to 0, then what will happen? C is equal to A. C is equal to A. And if it is 0, then what you will have? C is equal to B. And if it is 0, then you observe C times of A plus m, m plus n minus an minus bm is equal to 0. So C times of m plus n is equal, take this as right side, then you will have an plus bm. An plus bm. Then c is equal to what I can write? An plus bm divided by m plus n. Now you observe we have to take c value lies between AB. So can you guess which value is belongs to open AB? Is it belongs to open AB? No, because this is end point. And what about this? This is also not. So belongs to open AB. Hence proved the Rolle's theorem in this case. Okay now. Next problem. We have log of x square plus ab by x into a plus b in closed interval AB where a greater than 0 and b greater than 0. Now we have to verify Rolle's theorem for this problem now. Now you observe log a by b form. We have a logarithmetic formulas, some useful formulas. Log a by b. Okay, first log ab, product of the function. Then log ab, how you can express? Log a plus log b. Next log of a by b, how you can express? Log a minus log b. Next log a to the power of m, how you can write? M into log A. So we have to use these formulas to solve the above problem, right? Now f of x, how I can express now? Log of x square plus ab minus log x times of a plus b. Now here product is there, so use this first one. Now you use the second formula, log a by b form. Now log ab. Now even if you this one you can write as log of x square plus ab minus log ab is nothing but log a plus log b. But here you have minus, minus into plus, minus log of a plus b. That's it. Now you observe. Can I write this as log x square plus ab? Can I write 2 times of log x square plus log x plus ab? No, because log a power m you can write, but not a power m plus b. That you have to remember. Now you observe, this is, you know that logarithmic function is continuous on r plus. This is log graph, you see. Like this. Plus r only. Here you have to observe the domain is r plus, not for negative. Negative values log is not defined. That you have to remember. Log 0 also minus infinite. Log 0 is minus infinite. Log 1 0. Log 0 is minus infinite. That you have to remember. Anyway, so log, this function is continuous, this one continuous, and constant function is also continuous. So entire the function is continuous. So f is continuous on closed AB. Why closed AB means here a greater than 0 and b greater than 0. Both are real numbers, positive real numbers. Na? So log is defined for positive real numbers. That is why it is continuous. Defined and which is continuous. Observe the graph of the log function. Right. Next one, f dash of x. We have to verify f is differentiable or not now. F dash of x, that is log derivative 1 by x square plus ab. X square plus ab. Inner derivative what I have? X square plus ab derivative is 2x plus 0. Minus log x derivative is 1 by x into inner derivative 1 plus constant derivative. Log of constant is constant derivative only na. Log of constant is constant. Constant derivative is what? 0. There is no rotation. There is no change. Rate of change is 0. Now f dash of x is equal to, I am writing simple 2x by x square plus ab minus 1 by x. Now f dash of x is exist. Why it is exist? First of all, where it is does not exist also we have to see. See, if denominator is 0, then what will happen? Function won't be exist. Means f dash of x does not exist. Denominator you observe x square plus ab. When it is become 0? If x square is equal to minus ab. Is it possible? Square is when you will get negative only for the imaginary case. I square is equal to minus 1. Not like for real numbers. If you multiplied two real numbers, that those may be both negative or both positive. You will get obviously positive only. Here a is positive, b positive. Obviously you will get result is what? Positive only. So x square never minus ab in this case. So this is defined. Next, when it is 1 by x does not exist means if x is equal to 0. When x is equal to 0, function is not defined. But here clearly they are mentioned both a and b are what? Is 0 belongs to closed AB? No, because a and b both are what? Positive, greater than 0 only now. Now, so this is also exist on open AB. Now f of a you have to check it. F of a is log of a square plus ab by a into a plus b. A square plus ab by a into a plus b means inside if you multiply it a square plus ab. So a square plus ab plus a square plus ab getting cancelled, then you will have log 1. Log 1 is equal to 0. Next f of b. F of b is equal to log of, now a square plus ab. Sorry, f of b means in place of x I have to substitute what? B. So b square plus ab by b into a plus b means ba plus b into b square. So b square plus ab getting cancelled. Then you will have log 1. Log 1 is equal to 0. So is f of a is equal to f of b or not? Yes, f of a is equal to f of b. So what you can say? Rolle's theorem can be applicable. Rolle's theorem can be applicable. Okay, now verification. Verification means first you consider f dash of c is equal to 0. Then we have to prove there exists at least one point c belongs to open AB. Now f dash of x, what I have? F dash of x I have 2x by c square plus ab, 2x by x square plus ab minus 1 by x. So in place of x you substitute c, then I will have 2c by c square plus ab by minus 1 by c is equal to 0. That implies 2c by c square plus ab is equal to 1 by c. If you cross multiply, 2c square is equal to c square plus ab. So take c terms are one side and the rest of terms are other side. 2c square minus c square is c square. C square is equal to ab. That implies c is equal to plus or minus root ab. Now you observe how many values you have? Two values. One is c is equal to root ab. Another one is c is equal to minus root ab. You observe a comma b both are what terms? Positives. So product is also positive. So root ab is positive, but c is negative. Is negative belongs to open AB, but AB are what here? Both are greater than 0 na? So is it belongs to? No. So which is belongs to? Plus root AB belongs to open AB. More than one C also will exist. No need of only single C. There exist at least one C. Okay na? Like this we can solve the Rolle's theorem problems. Thank you for watching this video. F of x is equal to e power x into sin x minus cos x in pi by 4 comma 5 pi by 4 interval. Next second problem is f of x is equal to x into x plus 3 into e to the power of minus x by 2 in minus 3 and 0 in the interval closed interval minus 3 0. Now coming to the first problem, you observe the given problem f of x is equal to e power x into sin x minus cos x. Okay, now you observe the given function is containing sine function and cosine function and exponential function. You know that sine function is continuous, cosine function is continuous, e power x is also continuous. So their combination is also continuous. So f of x is continuous everywhere. Okay, so in pi by 4 comma 5 pi by 4 is also continuous. Okay, next second one is f dash of x. We have to verify the differentiation na f dash of x. Now product of two functions, uv rule, uv old dash is equal to u dash into v plus v dash into u. Anyway, first term into second term derivative, sine derivative is cos x minus cos derivative is minus sin x. First term into second term derivative plus second term into first term derivative is e to the power of x. I will repeat again, f dash of x is equal to first term into second term derivative plus second term into first term derivative. Now this is exponential function. Here also you have exponential function. So f dash of x, what you can say, is it defined or not in the interval, open interval 5 by 4 comma 5 pi by 4, pi by 4 comma 5 pi by 4. Now also you can simplify this one. You see e power x cos x and anyway first I am simplifying, e power x into cos x plus e power x into sin x plus e power x into sin x minus e power x into cos x. So minus e power x cos x plus e power x cos x getting cancelled. So the remaining term what I have? 2 e power x sin x. This is f dash of x is exist in open interval pi by 4 comma 5 pi by 4. That's it. Now you have to verify third condition, f of a is equal to f of b or not. F of a, what is a you have? Pi by 4. F of pi by 4 means in place of x you have to substitute pi by 4. You observe sin pi by 4 is okay, e power pi by 4, sin pi by 4 minus cos pi by 4. Sin pi by 4 is how much? 1 by root 2 minus cos pi by 4 is also 1 by root 2. So 1 by root 2 minus 1 by root 2 0. 0 into e power pi by 4 is 0. Next f of 5 pi by 4. F of 5 pi by 4. Then e to the power of 5 pi by 4 into sin 5 pi by 4. Sin pi by 4 is minus 1 by root 2 and cos pi by 4 is also minus 1 by root 2. Now in this case minus plus both getting cancelled. 0 into e to the power of 5 by 4 is also again what? 0. So from this what you can say? F of A is equal to F of B. Therefore Rolle's theorem can be applicable. Rolle's theorem can be applicable. Okay, verification we are doing. In this verification, first we have to take f dash of c is equal to 0. Now we have to prove there exists at least one c belongs to open interval AB. Okay, now f dash of x is equal to, we have 2 e power x into sin x. Then f dash of c is 2 e power c into sin c. This is equal to 0. You observe product of three functions. Here it is a constant. 2 is not is equal to 0. Next we have e power c is there. E power c is anywhere 0? No. In the interval pi by 4 comma 5 by 4, e power c is 0? No. Only e power minus infinity is 0. Okay, next sin c is equal to 0. When sin c is equal, from this what you can say? E power c not equal 0, 2 is not equal 0. Therefore sin c is equal to 0. When sin c will be 0? If c is equal to plus or minus n pi. Plus or minus n pi. Nothing but c is equal to plus pi, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. So from this, which are belongs to open interval pi by 4 comma 5 pi by 4? You tell me. Pi is belongs to pi by 4 comma 5 pi by 4. What about 2 pi? 2 pi is outside of pi by 4 comma 2 pi by 4. So here there exists c. What is that c? Pi. Okay, next problem. Friends, now given problem is f of x is equal to x plus 3 into x plus 3 into e to the power of minus x by 2 on minus 3 comma 0. So now the given problem you can also write as x square plus 3x times of e to the power of minus x by 2. The first term and second term here we have, you observe, product of two functions. Here first one is algebraic function, second one is exponential function. Now you observe in minus 3 comma 0, you give any value in between minus 3 and 0, including minus 3 and 0. Okay, now if you given, will you get finite value or infinite value? Finite only. So what you can say now, f of x is defined. So in this case you know that x square plus 3x is a algebraic polynomial of degree 2, nothing but quadratic polynomial, and it is exponential function. Exponential function is continuous and algebraic polynomial is also continuous. So the product of two functions is also again what here? In this case continuous. So f is continuous on closed interval minus 3 0. Next check it, f dash of x is exist or not. Now f dash of x, we have to do the UV rule. First term into second term derivative is e to the power of minus x by 2 into inner derivative minus 1 by 2 plus second term e power minus x by 2 into this derivative is 2x plus 3. That's it. Now you observe from these two what I can take common? E power minus x by 2 is a common. Then you will have the remaining terms is minus of minus 1 by 2 times of x square plus 3x plus 2x plus 3. That's it. F dash of x. Now is f dash of x is exist or defined on open interval 3 comma 0, we have to verify. So if you put 1, you are getting finite value. If you put 2, minus 1, minus 2, in between minus 3 comma 0, you will have finite value only. This is algebraic polynomial. This is exponential function. So these two are defined on minus 3 comma 0. So f dash of x is exist. So f dash of x exists na? Next we have to verify third condition. This is second one and first one is continuous, okay, and the third one is we have to verify the images and images. So f of a is equal to f of minus 3. If you put minus 3, what will happen? You see, in place of f x minus 3 times of minus 3 plus 3 is how much? 0. So this is equal to 0. Next f of b. F of b is nothing but f of 0. If you put x is equal to 0, 0 into this non-zero term will become what? 0. So f of b is also 0. So from this what you can say? F of a is equal to f of b. F of a is equal to f of b. So from this what you can say, Rolle's theorem is applicable or not? Yes, Rolle's theorem is applicable. Now verification. What we have to do in the verification means we have to take f dash of c is equal to 0 and we need to prove at least one c belongs to open AB. That's it. What is f dash of x? We have this one, e to the power of minus x by 2 times of minus 1 by 2 x square plus 3x plus 2x plus 3 we have, right? Now f dash of c means e to the power of minus c by 2 times of minus 1 by 2 times of x c square plus 3x plus 2c, sorry, this is c. In place of x we have to substitute c, okay? 2c plus 3 is equal to 0. Now you observe product of two functions are there here. Product of two functions are then, so e power x means exponential function never 0. So obviously this term will be 0. What is the term you have? You see, minus 1 by 2 times of c square plus 3c plus 2c plus 3 is equal to 0. So do the LCM for this. And so what I have means minus c square plus 3c. So this is 2 times of 2 means 4c. 2 times of 3 is 6 is equal to 0. So minus c square and this is plus 7c. Next you have like your plus 6 is equal, sorry, this is minus 3c and this is plus 4. So only plus 1 you have, plus 1. So on simplifying you can write c square minus c square minus c minus 6 is equal to 0. So if you simplify this one, c square, 6 factors are 3, 2, but minus is there, na? So you can also write minus 3c plus 2c minus 6 is equal to 0. So from this you can take c common, so c minus 3. From this you can take 2 common, then c minus 3 is equal to 0. So you can also write this as product of c minus 3 times of, sorry, c minus 3 into c minus 2 equal 0. c minus 3 into c plus 2 is equal to 0. Therefore c is equal to 3 comma minus 2. So in 3 comma minus 2, which are belongs to open interval minus 3, 0, check it. 3 is outside, 2 is, minus 2 is inside. So 3 is outside, 3 is outside and minus 2 is inside. Therefore c is equal to minus 2 belongs to 0, minus 3 comma 0. Friends, you remember you will get at least one c. Okay, more than one also you will get. That you have to remember. Sir, in all problems we are getting one root only. So why they are written at least one means I'll explain. You see, graph of the function. Suppose this is the graph of f of x. If you have, see, this is endpoints. If you consider a comma f of a and this is b comma f of b. Suppose you observe this graph is having continuous path or not? Yes. So which is continuous on closed AB. Next you observe, is there any sharpness in this curve? No. So this is differentiable on open AB. Next endpoints you take f of a is equal to f of b or not? Yes. So now there exists, by Rolle's theorem, there exists at least one tangent. Graphical representation is there exists at least one tangent which is parallel to the x-axis. So you observe now there will be parallel to the x-axis. How many are there? 3 are there. Like this, more than one. Every time one. For this only you will have 1. But for this you have 3. So based on the given function, we can say at least one c belongs to open interval AB. Okay, this is the Rolle's theorem. Thank you for watching this video. In the next video we will discuss Lagrange's mean value theorem problems.